How the world tackles the challenge of energy generation represents one of the pivotal questions of our time. Current trends in energy supply show the world's energy usage is unstable economically, environmentally, and socially. Our use of fossil fuels as primary energy source has led to an untenable increase in atmospheric pollution and put global warming at the forefront of scientific debate. At current levels of energy production, global greenhouse gases will double in 30 years. The world needs an alternative. Something has to change.
Renewable energy resources are one alternative. Solar and wind energy are some of the cleanest forms, together supplying 3.6% of world demand. However, we pose another form.
What's that?
Hydropower. Given the intermittent nature of solar and wind power, hydropower provides comparatively more reliable electrical power production, which has made it the most utilized renewable energy resource. At 3,500 terawatt-hours annually, hydropower provides the biggest proportion of renewable energy, accounting for 16% of worldwide production. However, hydropower requires space we don't always have. This is where microhydro comes in. This mini version is more cost-effective and environmentally friendly, presenting a practical solution for rural electrification in undeveloped countries and small-scale hydro development in well-developed nations.
So what is microhydro?
It's a hydroelectric power system that uses the flow of water, usually from rivers, to produce up to 100 kilowatts of electricity. This source of energy is cheaper and smaller.
What are the main benefits?
Microhydro works at reasonably low water flow rates, meaning it's available almost 24/7. Microhydro electricity is produced with zero emissions. The energy resource is flexible so that it can fulfill changes in demand. And as previously mentioned, it has low maintenance costs and can power small homes and businesses in remote locations.
So, what's the current status of microhydropower?
In 2009, 3,500 terawatt-hours of electricity was generated by hydropower.
And the potential?
Potential falls into two categories, technical and economical. Technically, 14,500 terawatt-hours per year can be generated. Of this, 8,000 terawatts per year is economically feasible. That's 75% of undeveloped potential.
So, how does microhydropower actually work?
The layout for a typical microhydro system is shown here. We start with the intake of water at the top, which flows past a man-made barrier called the weir. This directs the flow to form a canal, which forms into a forebay. The forebay removes debris to prevent damage to the turbine blades. The steep river gradient along the penstock generates the high speed in the river flow before entering the powerhouse.
So, what are the main considerations that need to be made?
So, the main considerations are the location, the turbine to be selected, and the generator that will be used.
So who's currently the big player in microhydro?
40% of the world's hydropower potential is situated in China. The government has invested huge amounts of capital into microhydro to provide 80 million rural Chinese citizens with constant and reliable electricity.
So what are the key challenges of microhydro?
Firstly, flooding could disturb the microhydro structure as it will cause variations in the flow. Additionally, the system is site-specific due to the seasonal variations, so the power generation per site is affected by river velocity. For this reason, the height difference will significantly impact the power profile. This is why location is so important.
What are the potential opportunities that microhydro can create in the future?
The main area could be hybridization. Currently, there are many ways to incorporate other green energy technologies, such as solar and wind power.
So ask yourselves, are we the generation that's going to solve the energy crisis?